Okay, welcome, Alex and Tina and Victor and Island and Donald and Terrence and Constance and Aria and Lauren. Thanks for coming. We'll be um, we'll be talking today about confidence intervals. That's the main thing. So what we're going to be looking at with confidence intervals, we're going to be looking at how do you use the sample to infer things about the population. This is a big day. So that pretty much almost everything we've been doing lately has been getting set up for today and for next week, by the way, too. So that is the plan of the day. I want to talk about one thing first, and that is there's something big that's coming up in 2 weeks from Wednesday. Anyone know the big thing that's coming up? That 2 weeks from Wednesday or before is fine. So in a couple weeks, yeah, the midterm. So I want to mention something is that this is the time when you want to start really preparing and deciding who you can take that midterm with, who your proctor is going to be. And I want to show you something that is required by next week, and not a week from Sunday, but actually it's the one main thing that's due on a Wednesday and not on a Sunday. And that is you have to give me the information for the midterm. Don't email it to me. A few of you thought that's what has to happen because you haven't gotten to next week yet. But let me show you just so you know how to do it. Let me go ahead and pop in. Where is it? Okay, so this is the module, and this is week 6, but if you go to next week's module, you'll see there's something called midterm information. If you click the midterm information, it'll look like this. And there's just a few questions I ask. One is, what day will you be taking the midterm? The midterm must be taken by 2 weeks from 2 weeks from Wednesday. So this coming Wednesday is what, the 23rd, then the 30th, and then the 6th. So November 6th. But you could take it November 6th, November 5th, November 4th, November 3rd. There's lots of days you can take it. So pick a day. I've written the midterm. Honestly, you could take it like tomorrow, except you haven't learned the stuff you need to learn to succeed on the midterm. So I strongly recommend don't taking it this early. But usually within 5 days before that Wednesday is fine, and that Wednesday is fine also. Question 2 is, what is your proctor's name and organization? If you're using Lake Tahoe Community College's proctor, just write LTCC, that's enough. I know about our proctor center, there's no problem with it. On the other hand, if you're not using the Lake Tahoe Community College's proctor, then I need some information. So I know who I'm sending it to and where I'm sending it. Question 3 is, what is your proctor's email? So you send me the email because I'm going to be emailing your exam to your proctor. So if the proctor doesn't have an email, it doesn't work. What is the proctor's web page? So I need a link to the web page. What I do is I go and research, go to that web page, make sure it's an official proctor center so that I can go check, yep, that one works. Whereas if it's just a friend of yours, that's not going to work. So that's the main thing with the proctoring. And that's it. So those are the 4 questions that you need to do this by a week from Wednesday. You could do it today if you wanted in terms of setting it up. 2 people have already done it, and that's great. I've actually already sent the midterm over to someone. And so early is okay, late is not okay for 2 reasons. One is I take 5% penalty off on your midterm, and that hurts. So there's no reason to do it late, do it now. The other is that if you do it too late, I'll send it to your proctor. The proctor won't get it in time. You'll get to thinking you're going to take the test and there's no test for you. So I can't send the test to a proctor if I don't know who the proctor is. So that's absolutely necessary to let me know who it is. Are there any questions? We got one in the chat, just a minute. You gave me the web page for the library, but there's pretty much nothing on it. Does that matter? I'll find it. I'll look, I'll do my research. So if there isn't much on the web page, no, I'll find it. If it's a broken link, that's not good. You could take as long as the public library allows proctoring, that's great, Victor. You could take it to the public library as long as the librarian will proctor it. And that definitely works. Yeah, so public libraries are a really good place to take it because I think they don't charge. I'm not sure, but I'm pretty sure you don't have to pay anything, and not paying is probably a good thing. Okay, but you have to make sure they do it. So do it ahead of time. Don't wait, and they have to be open when you want to take it. So if you want to take it, you know, in the evening and the library closes at 5, that doesn't work. Okay, so make sure that you're going to be taking it in a day that the library or whoever it is open. So if they're not open, you can't take it. Okay, I know that sounds obvious, but I'm telling you, this kind of things, people think that it's going to work and it doesn't. So make sure you talk to them first and then fill out the midterm information quiz. Okay, and public libraries are great. The other one I mentioned on the webinar, on the orientation webinar, is if you're in the military, I always accept your commanding officer because I know there's all kinds of issues with being in the military. You could be in Afghanistan, and there isn't going to be a public library where you're stationed in Afghanistan. Good luck. But you're, and by the way, it sounds far-fetched. It happens every year. I get someone from in Afghanistan in the military, so that's why I'm mentioning it, or some other place that they might be in the military. So I do get some active military people, which is great. I think it's a wonderful thing is to take an online stats course while you're in the military, especially if you have just time to sit around waiting and hopefully you don't have to shoot anyone or whatever you're doing. And it's much better to be doing statistics than sitting around waiting in fear. So definitely, you know, military is a great thing. Any other questions before we get into today's big material? Any questions? Okay, what I want to do is I'm going to do a survey. And for this survey, first thing is the chat box is not something people can see on YouTube. So I'll let you know this is not public to the world. And I'm not going to name you with your answer. So if you don't feel comfortable answering the question to the world, that's not a problem. But I think you guys find out. Okay, I'm going to ask you a survey question because I want to find something out. And that survey question is the following, and I'm going to pop this guy in here. And I'm going to go to OneBearStats. I'm going to fill out the last stuff we had. And I have one question for you. The question is, how old were you when you experienced your first passionate kiss? Okay, and that's passionate for you. You had to be wanting it. Okay, if you were molested, let's just not go there. Hopefully that didn't happen. Okay, and I just need a number. You don't have to tell me the exact truth, but give me something reasonable because I don't know you anyway. And I'm going to type these things in. We have a 15, an 18, a 16. Keep going. So how old were you? I want answers from everybody. 14, 16. Oops, gotta put it here. 14, 16, 14, 15. Okay, so we got 7. How many are with us now? There's a bunch more of you. There's a 13. Always amazed at this, and I'll tell you why a little later. Any others? Okay, because I want to get as many as we can. We get 8, we got 8. Okay, so what I'm going to do, I'm just going to jot this down. This is one of the things I can't prepare for because I don't know what your answers are going to be. Is the mean. So the mean, this is sample mean, is 15.125. By the way, that's X bar. Our standard deviation, sample standard deviation, is definitely a sample, is about 1.55. All right, so now I want to go and share a different screen. I want to share my Zoom. my paint, not Zoom. Okay. And I want to look at this and want to think about, well, I'm going to make a few assumptions. The first assumption, and see what we need. First assumption is that this is a random sample. Okay, this is not a random sample. We're going to assume it. We have to do that. Again, there's no way I could do a random sample asking you guys. That's not going to work. This is just a sample. It's very much convenient sampling. Do I need to assume the population distribution of first kiss ages, is normal? What do you think? Do I need to assume that the distribution is normal? And I'm seeing some people say yes. Now, how come? If I'm looking at sample means, yeah, here, notice it's quantitative, and we have fewer than 30. So we need to assume that we have a normal distribution, but maybe I should write this down. Assume random, okay, or representative. Assume normal. And there's one more thing I need to assume, and we'll find out there's ways of getting around it, but for now, we're going to assume that the standard deviation of the sample is the same as the standard deviation of the population. Or in other words, S equals sigma. Otherwise, I can't do calculations because the central limit theorem needs sigma. Is that clear? All right, so now what I want to do is draw a picture. With those assumptions, I can make my wonderful picture. It's about as straight a line as I've ever drawn. I don't know how I did that. There we go. Okay, so there's a beautiful picture. And what we can do is we're going to say, well, what is our best estimate? What is our best estimate for the mean of the population? What's the best estimate? What's your best guess based on what we've just done for the mean of the population? Yeah, 15 something, I like that, 15.125. And that's because that's our sample mean. And remember from last week, the sample mean is an unbiased estimator of the population mean. So that means I can say, well, that's going to be my best guess. Now, is that the population mean of all Americans? What do you think? Or how about all community college students is probably better. Okay, definitely not. It's just a guess. So now here's the hard part. How good is our guess? How close are we? Okay, how close are we? Given these assumptions, how close are we to the mean of the population? How confident are we that it's pretty close to 15.125? And that's the big question of the week, is how confident are we and how far do we go? So I'm going to draw more with the picture. So what I want to do is I'm going to draw best I can. And I'm going to say, well, I want to be 95% confident when I talk about a range of values that I think it might be. Any questions on that statement right there? I don't expect you to know the details and the formalities, but does it kind of just somewhat feel good? Any questions on that? Okay, so now what we want to do is, and let me write down a few things. We are assuming that S equals sigma, so we're going to assume that sigma is equal to 1.55. Okay, we're going to make that assumption. So what we need to do is we need to figure out what is this value. I'm going to call it L for lower bound. And what is this value, U, for upper bound? And how do we get those values so that we can say that we're 95% confident that the mean age of first kiss is between those two numbers? Do you remember what button in the calculator or what feature of the calculator we need to be able to find L if we know an area? Any thoughts? So what are we going to do on our calculator? Yeah, that's going to be an inverse norm. But the calculator can't handle the inverse norm when we've drawn that middle side. It can only handle this left-hand side. Do y'all know that? That's what the calculator can handle. So now comes some math, very basic math, is if the area between L and U is 0.95, what's the area to the left of L? See if you can come up with that. Yeah, it's going to be 0.025 because if there's 95% inside, there's 5% outside, but half of that will be on the left and half will be on the right. So that half of 5% is 2.5%, which is 0.025. Any questions on that? Okay, now let's see if you can tell me, using the inverse norm feature, what L is. Let's see if you can do that on your calculators. So it's going to be inv norm. I'll even type in what you're going to need. We're going to have 0.025, comma, 15.125, comma, and 1.55. Let's see if you guys can tell me in your calculators what that is. Okay, so Tina says about 12. I'm going to round it to the, since it's 12.1, maybe 12.1 is better. So that tells us that L is equal to 12.1. Okay, and by the way, let's just say, just round to one decimal, let's say the mean for now is 15.1. So now what we can say, we don't need to do another inverse norm, because what do we know? If we know L, without using your calculator really, how do you find U? I know L is 12.1, I know the mean is 15.1. How do I find U? Yeah, I add, I say, well, 12.1 is 3 less than 15.1. So that means I need to go 3 more than 15.1. So that means U is going to be 18.1. Any questions on kind of how I came up with this? It turns out when we do this in practice, we're not going to do all of this work. But I wanted to show you how this all comes up from what we've been doing last week and the week before. All this comes from what we've been doing. Because what's going to happen is you're going to use your calculator a quicker way, and you're going to have no idea what happened. So it's important to understand what just happened. There's the math behind what happened. It's not that hard, is it? Hopefully you agree. All right, so now I want to interpret it. Let's interpret this confidence interval. How about in green? And I have a lot of writing, so I'm going to make it a little smaller. Interpret the confidence interval. And what we can say is that with 95% confidence, the population mean age of first passionate kiss is between 12.1 and 18.1 years old. Any questions on that? Any questions? All right, so now I got a question for you based on what we've just done. If we want this 12.1 to 18.1, you know, 12 years old to 18 years old, that's a huge area. If I wanted to make that narrower, how might I do that? And there are two answers, by the way. How might I make it narrower so that I have better information? Because 12.1 to 18.1, that doesn't tell you much. Yeah, sometime middle of middle school and graduation from high school. Well, that kind of everyone knew anyway. But if I wanted to make it a narrower confidence interval, what would I do? Any thoughts? It'd be nice to be narrower, then I'd have better information. Okay, good, good. One way of doing that is to increase the sample size. So remember, the sample size has everything to do with the standard error. That was sigma over the square root of n. Remember that? So if you increase n, that decreases the standard error, and decreasing the standard error is going to make sure that L and U get closer to each other. It's all about the standard error. Is that clear? So what you really want is we look at this 12.1 to 18.1, you say, you know what, our standard error is too big. We're not happy with standard error. We want that standard error to get smaller. How do I do that? I increase the sample size. Okay, so I just want to let you know, and this is really important, you need to talk about that on project 2. This is the first day I even mentioned project 2, now that project 1 is over. So you're going to need to talk about that. Project 2, a big part of project 2 will be confidence intervals. And you're going to have to understand how the standard error affects the confidence intervals width. Any questions on that idea? All right, what if we couldn't increase the sample size? All right, I only have you guys, okay? I don't have any more time. I need to get it done. What else could I do? What's the other way? There are 2 ways to make that confidence interval narrower. Okay, decreasing sigma, that sounds like a really good idea, except what is sigma is the population mean, population standard deviation of all people's first kiss. I think the only way to decrease sigma, either we could like have more education in school to keep all those 12-year-olds or whatever from kissing so young, maybe make sure that everyone before they graduate from high school gets a boyfriend or a girlfriend. That is like impossible. Do you agree, Victor? So decreasing sigma isn't gonna happen. You can't do that. You'd have to change society to decrease sigma. Is that clear? So that's not an option. Okay, it'd be great. You know, I don't know if it's great. Maybe it's good to have a variety of people, but you can't do it. Sigma is sigma. You can't ever change it. Any other thoughts? There is another way, but there's a trade-off, but there's another way. And it has to do with the picture. Okay, I don't see everyone jumping in. So I want this L and U to get closer. So let me just draw it closer. Let's make it over here. And what I can do is I can say, I'm just going to do it here. There we go. There's L and U. Yeah, not the error. The confidence level is what we call it, Tina. Yeah, so I can decrease. I could do, instead of 90%, maybe I could do 80%. Do you see that? The area got smaller, and that's going to suck L and U in. Any note why don't we just make it really small? Because then you could really have good information. What's the problem with that? It's weak. So let's look at what it means to be 95% confident. And that's the next big question of the day. What does it mean to be 95% confident? So let's write this down, and we call that the confidence level. And let's do that in a different color. How about this, I don't know, burgundy or whatever you call that color? So interpret the confidence level. Okay, I want to let you know that's a different question than interpret the confidence interval. Don't get them confused. Or if I say, how do you interpret 95%? That's the same thing as interpret the confidence level. Whereas interpret the confidence interval is the same as interpret your results, because the results are the interval. Okay, so they're different questions, and I want you to promise me that you won't get that confused when I ask them on the midterm. Notice the word when, not if. Okay, you will be asked on the midterm and the final to interpret, and you have to know what to answer, and they look very different. So to interpret the confidence level, what we want to look at is realize that these are probabilities. Probability means that if you do it a bunch of times, what fraction of the time is it going to happen? Does that make sense? That's what probability means. So what is doing it? So in this case, doing it means collecting a sample. And here our sample size, I don't think I wrote it down, so I got to grab it over here just a second. Our sample size was 8. So what we can say is that if we did it a lot of times, so if many groups of 8 students were surveyed. Okay, well, these 8 students, you guys, got a confidence interval from 12.1 to 18.1. Do you all agree? That's what we got. If I asked a different 8 people, are we going to get the same interval? No. In fact, I asked a different, was it 8? It was, I think it might have been 9, but I'll pretend it was 8. 8 people earlier today. Why do you think I asked 8 people earlier today? Or 8 people that answered? Not preparing, actually. Something you may not even remember I said once. This isn't the only stats class I teach. Do y'all know that? I teach another statistics class. I teach a face-to-face class. Yeah, I asked the classroom. A few of them wouldn't answer. So I didn't have as many as the whole class as I should, just like not all of you answered. So I pretend I had only 8, and I got actually 15. I didn't get 15.125. I got a different confidence interval than what you gave me. Every time I do this, I get a different confidence interval. So each time, I will get a different confidence interval. So a different confidence interval will be produced. Okay, so I got this confidence interval from y'all that was between 12.1 and 18.1. Is that a successful confidence interval? Any thoughts? Was that a successful confidence interval? I want a yes or no from all of you, hopefully. That 12.1 to 18.1. Okay, so I'm getting yes, and here's the thing. Yes is a smarter answer than no, but we don't know for sure. What does it mean to be successful? What it means to be successful is that the population mean age is somewhere in between those numbers. If the population mean age were, say, 11 and a half years old, then no, it was unsuccessful. You didn't capture the mean. Do you see that? Or if it were 18.5 years old, we didn't capture the mean. If it was, say, 13.7 years old, we captured the mean, the population mean. So it may or may not be successful. We don't know. But of all the different confidence intervals you can get, what percent do you think will be successful? And that we do know, given these assumptions are true. What percent of all the different confidence intervals you could produce will be successful? And that's 95%. That's what the 95% means. So 95% of them will contain the population mean age of first kiss. So those are the ones that are successful. The other 5% will be unsuccessful, and they won't contain the true population mean age of first kiss. We don't know if ours is successful or not. I have no idea. Okay? I just know what I got. Okay, any questions on interpreting the confidence level? Okay, so again, there's a lot of things here. Notice the word population mean. That needs to be in there. Okay, population mean is part of this in this case. Standard error. So standard error is by central limit theorem. Let me write that down. Let's see, brush, red. That was sigma sub x bar. And that is by central limit theorem, sigma over root n. Any questions on that so far? Okay, so in our case, given the assumption that S is sigma, which is probably false, but I'm using that assumption, I get 15.125 over the square root. Ah, lost it. No, what happened? There we go. Over the square root of n, which was 8. So that's a standard error. It tells you how wide the normal distribution is. Okay, so if the standard error is very small, then it's going to shoot right on up. If the standard error is if the standard error is small, it's going to shoot up. If standard error is big, then it's just going to kind of go like that and not go so high. Oh, sorry, I have that wrong. You're right. Sorry about that. Thank you. It's not 15.125. Sigma was 1.55. So let me fix that. Thanks. That was our sigma. Okay, any other questions? Does that make sense on what the standard error is? So standard error helps you in terms of if you have a small standard error, you can have a narrower confidence interval. The only way to change the standard error is by changing n, because sigma can't change. Sigma is fixed in the population, and you get to choose. Any other questions on this? All right, now what I want to do is I think I want to show you how to do this with a calculator. So I'm going to reshare. And I want to mention something. There's a big assumption we made, which is completely false. And that is that the population standard deviation is the same as a sample standard deviation. And that's just wrong. And there's a way to get around that. And this was actually found out by a guy who was testing beer. Okay. He was testing beer and he realized that he wasn't getting 95% of his confidence intervals to contain the population mean, because he was assuming that sigma was the same as S. So he came up with the math, which I'm not going to do. I'm just going to tell you how to do it on the calculator to adjust for that sigma not being the same as S. And he called it the student's distribution because he was, I think because he was working for a beer company, and he didn't want anyone to know that he was actually being nerdy and doing statistics and like doing new mathematics. So he called it student, and that's just the way it is. So let me show you how we do this. I'm going to go to stat. First thing, I got to put my numbers in. So I'm going to go and I want to clear out what I had. So you've done this before. I hit clear, enter. Then I'm going to type in my numbers: 15, 18, 16, 14, 16, 14, 15, 13. Any questions so far? So I just put my data in. Then I'm going to go to stat again. I'm going to go to tests. And I want to let you know there are a lot of tests. This goes on and on and on. We are halfway through the course, not just about halfway through the course right now, not even quite. L2 doesn't matter, Tina. I'm not going to use L2, so it's okay to have data in L2. L1, I just needed to clear. Okay, so we have a lot of different tests here. That's what we're going to devote the entire rest of this class, just to go through each one of these tests. Okay, the test we're going to use today, for now, is t-interval. So t, because we're doing what's called the student's t-distribution. Interval, because we want a confidence interval. And by the way, there's only one t-interval. There's also, you'll see a two-samp t-int. That's if you have two samples instead of one. That's in 2 weeks. So we're going to do all these things, or almost all of them. We're doing the t-interval. It asks for data or stats. I have data, so I hit enter on data. Then it asks for the list, which is L1, so second one gives you L1. Freak is just 1. Freak is 1. Let's do a 95% confidence interval. C level stands for confidence interval. Confidence level, I mean. So 0.95. And then I calculate. Okay, and what we get is about 13.827 to 16.423. Any questions at all on calculating this confidence interval? This is how you do it with a calculator. And then you don't need the assumption that you have a normal distribution. The t will work. We still need to actually assume the population distribution is normal, but you don't have to, so you have to assume it's normal. You don't have to assume sigma is S. Yeah, that's because we're using t, which is better. So that's why it's different than the results. So remember I told you I had to make that a big assumption that sigma is S. And it was a wrong assumption, but I needed to show you to be able to understand how the math worked and the pictures. I showed you that, but now we're doing it this way. So Tina, it is a little different, and we're going to be using the t distribution because you're never going to know sigma is S. Okay. Definitely, there's a short video. Definitely have videos on it. And a long video does it too. Okay, any questions on this? All right, so next, what I want to show you is, let's show you how this is used in the real world. I mean, this was kind of real world, this is interesting, but I'm going to give you a news article, okay? And for the rest of the quarter, I can always give you a news article because stats is used everywhere, okay? Or research publication article. So let me reshare. That one is that one for now. And I want to do it this way. Just want to be able to see it myself. Okay, you should be able to see that. And here's the news article. This came up recent. This was a recent news article. Okay, and it says 95% of baby food had toxic heavy metals. Senator Schumer calls for action. You can't see it? Let me try one more time. Can you see it now? Okay, so 95% of baby food had toxic heavy metals. Senator Schumer calls for action. All right, so first thing is, anyone seen this article? Anyone read about this? Kind of scary, isn't it? Okay, came out today. Okay, kind of scary. October 21st at 12:56 p.m. And I want to read some of the issues. Now, do they know that exactly 95% of all baby food has toxic heavy metals? Okay, the answer is no. You say yes, no. It's absolutely no. They don't know about all baby food. You can't know that. This is just an estimate based on any guess? Any guess on what it's an estimate based on? Sample. Yep. So if I scroll down a little bit, they talk about it. And right here, according to the report, 95% of baby food containers tested had toxic heavy metals. Oh, baby. That does not sound good. The testing involved checking 168 containers. Okay, that's the main thing. 168 containers, 61 brands, 13 different types of baby food. So 61 brands, 13 types of baby food. That might be some kind of stratified sample. I don't know. They didn't go over that, but they did do some testing. Okay, so that's a big problem. So a couple things. Is the sample size big enough? So now I'm going to write down some numbers. So I got it. So we have 168. And then we have our 95%. And 95% of 168 is about 160. So you can stick that in a calculator. 0.95 times 168 is about 160. So now we're ready to actually find a confidence interval. But we need to do one thing first. I think I'm going to share my desktop on this. I mean, share Zoom, share my Paint again. I want to unselect this guy or get rid of all this stuff. Okay, how do we know if our sample size is big enough to do this calculation? So, any remember? All right, so I want to remind you, Tina, remember the survey question is this baby can toxic? The answer is yes or no. Do you remember what you promised? I think you were one that promised that you would never do if it was a yes/no question. What number would you never write down? Yeah, you never write 30. It's NP and NQ have to be bigger than 5. Okay, and that comes, if you remember, that was part of the discussion assignment from last week. Do you remember that? And most of you got it, actually, so that was good. But the hope is not only did you get it then, but hopefully you still remember. So NP was equal to 160. That was the number of yeses, or the number of cans that were toxic. NQ were the number of cans that were not toxic. Okay, so how many were not toxic? Here's the hint, there are 168 cans. Yeah, 8. Are we good enough? Are we good to go? Can we use the normal distribution? Yeah, we can, because NP and NQ are bigger than 5. Do you see that? These are both bigger than 5. So the sampling distribution is normal. Approximately normal. Any questions on this? Okay, we need that to happen, and now we can go to the calculator. Okay, if you go to the calculator and it didn't happen, you've got it wrong. Okay, so now let's go to our calculator. And let's go ahead and find a confidence interval. So I'm going to go to stat. I'm going to go to tests. And it's a different one. Any guess on, let's scroll down a bit more. I might have gone too much. Any guess on which one is the right one to do? Which one of these menu items should I do? And just to let you know, on the final exam, you're going to have to know them all. Okay? Just about every one of these can come up on the final. And question number 1 in the final will just be, that's all you have to do is you tell me which one it is. Okay, it is a proportion one. We're definitely doing proportions. There's actually a lot of proportion ones here. So what is on the calculator? Yeah, A, 1 prop Z int. So 1 means there was 1 sample taken. Prop means proportions. Z means we had a large enough sample size. And int means confidence interval. So each one of these little things means something. So I'm going to go to 1 prop Z int. And very simple, X was 160. N was 168. Our sea level, what do you think? 95%? Are you happy with that? Maybe we want to go higher. We don't want to be wrong on this. I don't know. What do you think? Or maybe lower. But you could do 95%, and we can calculate. Any questions on this? And what we get is about 0.92 to 0.98. I'll keep it 2 decimals. Probably enough for this kind of question is 2 decimal places of accuracy. My pen just fell down. There we go. All right, so now what I want to do is I'm going to do a new share. And let's interpret it. So with 95% confidence, it can be concluded that the proportion, or that actually even better, that between 92% and 98% of all baby food containers contain heavy metals. Any questions on that? I want to underline something really important that you will lose points if you don't put in. So if you're not going to use population proportion, you need to have the word all, because all means population. Any questions on that? Any questions at all on the confidence interval for a single population proportion? We use these formulas to find the population mean. That's not true. There's no mean here. This is a proportion. Does that make sense, Victor? Yeah, so we don't use this for a population mean. We use it to get an estimate for the population proportion. We didn't find the proportion. We got a range for where the proportion is likely to be. Do you see the difference? But definitely not the mean. Other formula. an accuracy range. I'm not quite sure what you mean. One thing you can say, and this is important, we had that the sample proportion was 95%. Notice 92 and 98 are 3% away from our sample. So the margin of error is plus or minus 3%. Let's write that down. So repeat what I said about the word all. So see where it says 95% confidence can be concluded that between 92% and 98% of all baby food containers contain heavy metals. If you didn't use the word all, I'll take off points. Because we're confident about the population, not confident about the sample. We're 100% confident about the sample. We know what we got. What we don't know about is the population, but we can be 95% confident about the population being between these two numbers. And the word all refers to the population instead of the sample. Janice, does that make sense? And again, this is the first week where we're using the sample to make an inference about the population. And that's pretty much the rest of this entire course, is to do that. Any more questions on this? Okay, what if, okay, I had a margin of error plus or minus 3%. What if I wanted a margin of error plus or minus 1%? Okay. Yeah, so I don't want to decrease my confidence. I want to keep it 95%. So I want to increase my sample. Now here's the harder question. So Tina, you gave me the idea. Let's increase the sample. How much do I have to increase it to? Okay, we did 168. That was N. And that wasn't good enough. Do we need to do 1 million? And that's a big question. So the key is there's a formula. And without the formula, we can't do this. So this is going to be a formula. And I think I need a brush. I'll do it in blue because we haven't used this, or purple. And this is N is equal to P times 1 minus P times Z over E quantity squared. Okay, I'm not even going to attempt to explain where this formula comes from, but you need to have it. You need to have it written down. And you probably don't want to memorize it. So good note sheet formula. Okay, so this is a formula, and this works. Notice the letter P, so it's only for the yes/no question. And this only works when we have an idea of what the population proportion is. P is going to be an estimate for the population proportion. In this case, our sample proportion, and sorry, I used a real article, so we got to deal with it. Yeah, it represents the proportion of yeses. P represents the proportion of yeses in our estimate. And in this case, it happened to be 0.95, because remember, 92 to 98, that was what they said in the article, was 95% of all food containers are bad, have heavy metal. So in this case, P is 0.95. Nothing to do with the confidence level there, by the way. So sorry if that's confusing. But it just real world, sometimes that happens, 0.95. E is 1%, and you got to know how to turn that into a decimal, 0.01. Z is harder. Any guess on what I'm about to draw? Yeah, bell curve. So there's what we want to do is want to find the Z, okay, that corresponds to 95% confidence. So again, we've done this before. That's 0.95. This is 0.025. Yeah, this is going to be a standard. That's a good question. If we use the letter Z, that means the mean and the standard deviation are 0 and 1. Okay? So this number comes from this. So what we're going to do is we're going to use the inverse norm. Oops, I want to go text. There we go. Of 0.025, comma 0, comma 1. Depending on your calculator, you may not need the 0, 1, but you can always do it and it'll work. And what do you get? Maybe about 1.96. So pop that in your calculator, tell me what you get. And it'll be negative. The negative doesn't matter because we're squaring it. So usually you just don't even write the negative. Yeah, about negative, you get 1.96 is good enough, rounded. Any questions at all on that? Any questions? All right, and now it's just plug and chug. So what we're going to do is we're going to say n is equal to, well, we have p, which is 0.95. Times 1 minus p, which is 0.05. And then times z, which is 1.96. Over e, which is 0.01. And then we need to square it. And the question is, what do you get? Maybe I'll pop it in too. You can stick it in your calculator. So what do you get? All right, Eileen, it's not that much. It's not 91 million something, that's for sure. Yeah, Tina's close. Yeah, Alex is a little better. Let me write it out and then I'll talk about it. Because this is one case where the math, what you learn in math doesn't work. But it actually works on this case, but doesn't always work. So what we get is 1824.76. So here's a new rule of rounding. When you're finding out how many people you need to survey, you always round up. Got it? Always round up. So we're going to do 1,825. Even if it had been 1824.21, you'd still go 1825. So we survey 1,825 people. Okay, and by the way, that's a big difference. It's a lot harder to do a survey of 1,825 people than it is to do it of 168 people. A gigantic difference. Okay, so just a note, it's really hard to change that, to change it to 0.01 instead of 0.03. Okay, it's a big, big challenge. Any questions on this? So you do 1,825 and that should do it. In the real world, by the way, you shoot for 2,000 and there's always, and you have a team of people that are doing it. And something I've learned is always flakes. And no, E is 0.01. Our goal was N. N was 1,825. This is 1,825 people. Okay. No, I mean of percent. I don't know what you're talking about, Tina.
So what I was trying to ask is, because you had said you wanted to try to, what can we do to make it plus or minus 1%? So is that where the 0.01 for E came from or not, the plus or minus 1%?
Yeah.
Or is just E always 0.01?
Yeah, so notice it says, if I wanted a margin of error of plus or minus 1%, do you see up there? Then increase your sample to size 1,825.
Okay, so the value for E came from that 1%. Thank you.
Exactly. That's where the 1% came from. Okay, any other questions on this? All right, I got another question. I'm going to start over. But we still have some more to do. 2 more things, actually. Let me go to, there to select. By the way, speak now because it's about to get erased if you don't want it to be erased. It's just not letting me do it. Huh? Try again. I don't know what just happened. Maybe I gotta do this. All right, start over. Sorry about that, but for some reason it wasn't letting me erase and select it all. So let me try one more time. Let's select, no, I want to go to Canvas. There we go. Okay, so let's say we want to do something different. Okay, the same idea, but a little different. Okay, suppose you wanted a 95% confidence interval for the percent of all Americans who plan on voting in the next election. Presidential election. If you want a margin of error of no more than 3%, how many must you survey? Oh, I don't know if you can see this, sorry. I just realized I think you're not seeing it, all right? We'll get there in a second. Better. How many must you survey? How many Americans do you survey? Any questions on the question? Any questions on the question? All right. This is different. How does this differ from the last example? There's a big difference between this one and the last one. Right? If you remember the last one, we had a formula. N was equal to P times 1 minus P times Z over E squared. How is this different? Why can't we do this? Where are you going to get stuck? Yeah, P. We have no idea what P is. So what we're going to do is we're going to use the P that makes this the highest possible, kind of the most conservative estimate. Does that make sense? And I'm not going to prove it, but I'm going to mention that if you look at P times 1 minus P, that from algebra is a parabola. And the top of that parabola happens when P is 0.5. So the biggest N we'll get is when P is 0.5. Everything else will make N smaller. So if we let P be 0.5, then we'll get a conservative estimate. So if you do that, now we can rewrite this as 0.5 times 1 minus 0.5. Well, that is 0.25. And that's times Z over E squared. How did I get 0.25? So if you don't want to do all the math, just remember 0.25. That's when you don't know what P is, then you got to use 0.25. It comes from the vertex of a parabola. I'm not going to go into the proof of the math, but that's where it comes from. So, but 0.25, it's a formula. This is when we don't know the population proportion or have no idea of the population proportion, use 0.25. Whereas if you do know, you plug in. Okay, so now that was 0.95. That is 0.025. And that was 1.96. I don't know if you remember that number, but we already talked about it once. So that's 1.96. E, by the way, is what? What's E in this case? Any thoughts? It's not 0.05. It's a good try. The hint is it's up on the question. It's the only number we haven't used yet. Yeah, 0.03. Because 3% is our margin of error. E stands for margin of error. So then we plug in 0.25 times Z, which is 1.96, over E, which is 0.03, and then we square it. And I can't do the whole thing in my head. It's over 1,000, not much over 1,000 though. But let's take a look. You should all be able to do this in a calculator. 0.25 times 1.96 divided by 0.03 all squared. And 1,067.1111. So how many people do we need to survey? Do we survey 1,067.1 person? $1,068. Remember, always round up. So survey 1,068. Any questions on that? Any questions? All right, ready for the third type? There's a third type. So let me do the third type. If it lets me do it. Okay, let me do it this time. All right, so now we remember, or you may or may not remember, but I have it written down, so I remember it. At least I know where it is on my paper. Is using the estimate of 1.55 for the standard deviation if we want a margin of error of, let's say, plus or minus, or margin of error of no more than 0.2 years for the age of first kiss. How many people, how about students, must we survey for a, how about just for fun, how about an 84% confidence interval? Any questions on the question? All right, I have a big question for you, and this is really important. How is this different from the other two examples? And the warning is we're not going to be able to do this without some more information or more, at least more math. How does this differ? No E. We have an E. E is 0.2. We're given standard deviation. Yeah, that's not the problem though. There's a bigger issue that we don't even know where to start. Why don't we know where to start? Any thoughts? Okay, the big difference is the survey question here is how old were you when you had your first passionate kiss? The answer is not yes or no. There's not proportions. There's no proportions here. This is a question that's quantitative, not yes, no. Remember, in this class, you always want to be thinking of that first. And when you have a question that is quantitative, then what you need to do is use a different formula. So let's do the formula. And that is n is equal to parentheses z sigma over E squared. Any questions on the formula? Another thing to put in a note card, one more formula. So today we got 3 big formulas you want in a note card, and you need to know how to use them and when. And these are for finding the sample size. So then what we do is, now let's go through, let's do the easy ones first. Sigma, we know. Hopefully y'all know sigma. What's sigma? Looking for a number. 1.55. It's our best estimate for sigma. It's all we can do. Okay, this formula comes from the central limit theorem. I don't have time to go over why it works, but trust me. E, we also know, that's easy. What's E? Yeah, 0.2. I'm gonna write 0.2, make it a little easier to read. Z, we draw a picture. That area there is 0.84. What's the left tail area? Yes, 0.08, because if there's an 84% chance of being inside, there's a 16% chance of being outside. Half of that is 8%. So 0.08, 0.08. So that's our Z. Sorry, Z is not 0.08, but how do you get Z once you know 0.08? Yeah, inf norm. So see if you guys can do the inf norm. I'm hoping you all know how to do it, that you don't need to see it demoed again. We've done a lot now. Yeah, about 1 point. I'm going to write 405 because it's like halfway between. Probably safer to go 1.405. On the computer assignments, carry a lot of decimals, by the way. So 1.405. So then n is equal to, and now we just go 1.405 times sigma, which is 1.55, over E, 0.02, 0.2, I mean, squared. Okay, and again, this is one hopefully you can stick in your calculator. I'm going to pop it in my calculator, Google Calculator. Okay, for some reason I can't see a chat, but I'll be able to see it in a minute. Let me just do new share. See if that works. There we go. Yeah, so 118.6, always go up. Don't use rules of rounding, always go up. You certainly do not ask 118 people and then go to another person and chop their legs off so you only get 0.6 of a person and then ask them after that. Don't do that, Alex. We just go 119. and you ask 119 people, and then you will get a margin of error that's acceptable. Any questions on this? Inv norm is a little off for you? 1.405? Yeah, I'm not sure why, but that's just, I just dropped it in my calculator. That's all I did. Just an inv norm, and then you just got to make sure you put in the 0 for the mean and the 1 for the standard deviation. And you put in 0.08 for your first number. All right, I have a secret word for y'all. And the secret word is 5. Any guess on why 5 is important? Any guess on why 5 is important? Not seeing y'all jump in. Yeah, when you have the yes/no question and you want to use the central limit theorem, you have to have NP and NQ greater than 5. And I notice that some of you use the number 30 today and also on your central limit theorem discussion board posts. So I want to make sure you've got that down in your brain, that when it's a yes/no question, not 30, it's 5. Got it? So that's the secret word. The word is really a number this time. And that's the secret word for this week. So I'm going to pause my share or stop my share. And that's all I have to say today, but I'll be happy to answer any questions you might have as always. So let me know if you have any questions. Alex or Tina or Victor, Island or Donald or Terrence or Constance or Anna Guadalupe or Brittany. Any questions at all? And as always, I'm happy to answer questions. If you don't have questions, I'm happy to say goodnight too.
That last example you did, how would we write the analysis of it, or the?
You mean how do you show your work, or how do you show your answer?
Like on the other ones you gave us, so we would say with 95% confidence can be concluded that.
Yeah, this one's not as
a conclusion.
The final, okay, so that's much these conclusions are much easier. So let me just redo it, and I'll pop it in, and you'll see. So let me do a couple things. Let's put it over here. Oh, actually, I need the 119. I need some space. Not a lot of space, though. So survey, 119 college students. Is that easier than you're trying to make it?
Yeah, that doesn't draw any conclusion. I guess it does. That's the answer.
Mm-hmm. Yeah.
Yeah, it's way less complicated.
Yeah. Yeah. I mean, you could restate the question and say, if we want a margin of error of no more than 0.2 years for the age of first passionate kiss, with a 95% confidence interval, survey 119 students. Do you see that?
Yeah, that's kind of what I was thinking you would expect.
Yeah. Yeah. But since I already asked the question's up there on that page. You don't have to rewrite that. Does that make sense?
Yeah.
Whereas on the other examples at the beginning, all that writing wasn't there already. Do you see? But for just finding the sample size, it's a very simple answer. The place where people have the hardest time is getting Z. Because there's a little work to do, and if you got to draw that picture. And when I give it to on midterms, I always give some number that you won't be able to memorize, like 0.84, just some random number. I'm not going to always give you 0.95 for that particular kind of question. Any questions?
But always 1 minus that number is going to give you the other side of it and divide it by 2.
Yeah. Yeah. And that's from geometry. I mean, you can memorize the formula, but just look at the picture. The inside's 84%, the outside 16%. So half that is the left side. So very geometrical. Okay. Let's see. Island said goodnight. So goodnight. Let me stop the share. We lost a few already. Any other questions, Tina or Alex or Victor, Guadalupe or Brittany? Okay, good night, Guadalupe.
That wasn't as much writing as you promised me.
The beginning was, wasn't it?
Not compared to what I normally take.
Okay. And then next week is going to be a lot more too.
Yeah.
And the week after, a lot more. So every week now we're going to have a bunch of writing. Whereas last week we didn't do much writing.
Thank you very much. You have a good night.
All right. You have a good night too. Victor says these are the only formulas we have to remember. First thing is you don't have to remember them. You just have to have a note card. You are allowed a note card for the test. Write small so you can fit everything. But those 3 formulas for N are the only formulas that really for this week, those are the formulas. But again, if you don't know when to use which, that's not going to help. So make sure you practice so you know when to use which one. Same formulas. I think I used EBA instead of E because that's what the book uses, but I like E better. So lately I've changed that. And I think I use Z sub alpha over 2 instead of Z. So the way I wrote them this time were kind of shorthand, a little easier to write down. But it's really the same formula. I just had more description of each letter. Okay, any other questions? Okay, you two have a good night. And Brittany, last chance in case you have questions. I haven't seen you. But I'll be happy to answer them. Otherwise, for all of you who are watching this as an archived webinar, have a really good night, good week. Don't forget, this is the time to start investigating when you are going to take your midterm and who you're going to take it with, and make sure you fill out that proctor, the midterm information that's due next Wednesday, but that's one of those that you can do early. So have a great night, and please post on the Q&A forum if you have any questions. Thanks.